Okay, so in this video I'm going to have a look at graphing sine functions, and in particular I'm going to have a look at graphing the sine of theta, sine of 4 theta, and 2 sine 4 theta. So let's see how they work. I'm just going to start with sine theta here. Now, I've actually drawn it here, but let's have a look at how I drew it. Now along the x-axis here I have theta, or the actual angles I'm going to find the sine of, and I put in a few angles here. I put in 2 pi, half of that pi, half of that pi over 2, and 3 pi over 2. So these are basic angles. In degrees, this would be 360 degrees, 180 degrees, 90 degrees, 270 degrees. So if you remember from a previous video, we did the unit circle, and whoops, this is roughly a unit circle anyway. Unit circle means it has a radius of 1. So this point here is going to be 1, 0. This point here is going to be 0, 1. This point here is going to be minus 1, 0. And this point down here is going to be 0, minus 1. Now remember as well that the x-coordinate is our cosine or our cos, and the y-coordinate is the sine. So if we take 0 degrees, this angle here, 0 degrees, the sine of 0 degrees is 0. So we put a point here. If we take 90 degrees, or pi over 2, our sine is 1 here. Our second coordinate, our y-coordinate, is 1. So we put a point here at 1. If we take pi, or 180 degrees, we get 0. So put a point here at 0. If we take 270 degrees, or 3 pi over 2, our sine is minus 1. So we go down here to minus 1. And if we go back around again to 360 degrees, or 2 pi, our sine is 0. So we end up back here again at 0. So this is our function here, going from 0 to 2 pi on the x-axis. But in fact, if you go back around the circle again and again and again, what you find is that this pattern will repeat over and over again to infinity out on the x-axis, and also in the negative direction out this way as well. So this function is called a periodic function, because this pattern here just repeats over and over again to the right and left. And we also say that the period of this function is 2 pi, because every 2 pi the pattern repeats. So we've gone out as far as 2 pi here. We just get the same pattern again, again, again after 2 pi. We also say the range here, the range of this function on the y-axis goes from minus 1 to 1. So we go from minus 1 here up to 1 here. So that's our basic sine function. Let's have a look at the next function, which I'm going to do, which is called, this is called the sine of 4 theta. Sine of 4 theta. So again, I've drawn the x and y axis, so I've drawn different values here. I've drawn pi over 2, pi over 4, and you'll see why in a minute. What happens when you multiply the angle by constant here is it squashes this function in. It squashes it in this direction and this direction. You'll see that in a minute anyway. So let's have a look. We have pi over 2 and pi over 4. So let's look at finding the sine of these first of all. Well, we take 0 first of all, actually. So I'm going to take 0. So let's see. We're going to look at the sine. We're going to take 0 here. So the sine of 4 times 0 is 0. So the sine of 0 is going to be 0. So I just put a point here. Now, if you take, let's say pi over 4 here. So if you look at the sine of 4 times pi over 4, sine of 4 times pi over 4, we get the sine of pi. It's the same as the sine of pi, and the sine of pi, as we saw previously, the sine of pi here is 0. So I can put a point here as well. Now if we take the sine of pi over 2, so you got pi over 2 times 4. Let's see what we would get for that. Well, we would just simply get the sine of 2 pi. Sine of 2 pi is 360 degrees. We also get 0. Now, if we take half of this, say pi over 8, so half of this angle here is pi over 8. That's 1 pi over 8, 2 pi over 8, This here is going to be 3 pi over 8. Let's try these two angles and see what we get. Well, if you take sine of 4 times pi over 8, that's just the same as sine of pi over 2. 4 into 8 is 2, so we sine of pi over 2, or the sine of 90 degrees, as we saw from our unit circle here, the sine is 1. So we're going to end up back up here at 1. So I'll just draw a point there. And 3 pi over 8, if we look at that one, so we're looking at sine of 4 times 3 pi over 8. That's going to give me, that's going to be the same as sine of 3 pi over 2, or 1.5 pi. So that's just going to be minus 1. So again, if I join those up, I get this kind of a curve here. Whoops. Down, around, and up again here. So what I can see here is that I've got a repeating pattern again. This will go up and down, up and down. But in this case, what I find is the period in this case is not 2 pi anymore, but pi over 2. Remember the period in the previous case was 2 pi. It was 2 pi here. So what actually happened here is that if you take that 2 pi, divide it by, remember we're multiplying the angle by 4, say divide by 4, you will get pi over 2. So the period is pi over 2 in this case. The range in this case doesn't change. The range in this case remains at minus 1 and 1. Okay, but what has changed is the period. The whole thing is squashed in, if you like. So instead of a period of 2 pi, which would be out here somewhere, we've now got a period of pi over 2. Okay, so let's have a look at the last one then, the next one we're going to do. And this is 2 sine 4 theta. So in this particular case, what's going to happen here, in fact, is each one of these values will be doubled. We're going to multiply our y here by 2. So all that really will happen here is that we'll end up drawing our curve at pi over 8 here. Remember, we were up at 1 in this case, but that's going to double now, so we're going to end up here. The zeros won't change, so we're still going to end up here. And this was minus 1, remember, so that will now be minus 2. So we'll end up with a curve like this, where the period here, from our original sine theta, was 2 pi. So originally it was 2 pi. We've got a 4 theta here, so we've got to divide by 4. So that just leaves us with pi over 2. So a period of pi over 2 here. So we end up with a period of pi over 2 again, same as up here. However, the range here has changed now. The range has gone from minus 1 to 1 in this case. Sorry, it hasn't gone from minus 1 to 1. It has actually gone from minus 2 to 2. We doubled our y here, if you like. So we've gone from minus 2 up to 2. So just have a look at that in this particular case here. What I have here is actually a sine wave here, or a sine curve here. So if you just have a look at this, I have 2 sliders here which I can move around. This is our basic sine curve. We start at 0, we go up to 1, we go through pi, we go down to minus 1, we go up to 2 pi, and so on. It repeats over and over again all the way out along here. Now this function is the sine of, this here is the sine of sine of x as it stands at the moment. Now if we had the, let's say, if we want to multiply the angle by, change the, this is 1 times the angle, if you like, 1 times theta. So this is the sine of 1 theta. If we change it to the sine of 2 theta, what should happen is this should end up here, this should end up half the distance, and so on. So let's have a look at that. Just going to move this out to, sorry, now I'm just going to move this slider out to 2, and look what's happened. Oops. going to move this out to 2. I can just, there you go. So what happened in this case, remember originally we went up to 1, down through pi, back to -1, and we finished here. This was one period. I multiplied the angle by 2, so this is the sine of 2 theta, sine of 2 theta. So look what's happened. The period has now halved from 2 pi to pi. The sine of 0 is still 0. The sine of pi is pi. The sine of pi over 2. Sine of pi over 2 here. Well, this is actually 2 times pi over 2. 2 times pi over 2, which is just sine of pi is 0. So everything is just halved here. If I bring this back to 1 again, so let's see, bring it back to 1. This was my original function here. If I can get this to stop at 1, there you go. This was my original function. Now this here is a constant in front. This was let's say this is 1 times sine 1x currently. 1 times sine 1x. So if I change this 1 in front of the sine to 2, for example, we would expect this peak here to go up to 2, this peak here to go down to -2. So if I move this to 2, this is 2 times, I'll change it from 1 times sine x to 2 times sine x. So let's just move this out to 2. You can see what happens here. I've moved it from here up to here, and from here down to here. Okay, and you can see what happens as I change the constant in front of the sine, the range changes. So if I move it to 3, it'll move up to 3. If I move it to 4, it'll move up to 4. And in fact, if I go negative, it'll switch around, as you can see. So that's what happens when I multiply the sine by a constant. So I'll just move this back to 1. Move back to 1 again. There you go. There you go. There you go. There you go now. And this here is the constant that's in front of the actual angle. So currently it's sine 1x, or sine 1 theta. And as I move that out, it squashes in. As I move it back, it just flattens out. Okay, so that's it really for sine functions.